In this video, we're going to look at linear number patterns with unknown or variable terms. Okay, there's a slash missing here. But anyway. So in this question, we are given 3 terms. It's very tricky to see, so that's why you have to be on the lookout for your semicolons, because semicolons tell you where the term starts and whatnot. So this is term 1. Then only 2x is term 2, and then this whole portion over there is term 3. And they're telling you it's linear. When there's variables involved, they have to tell you it's linear because there's no way of you knowing it straight from there. And then because you know they are linear, you should be knowing, or you should know, that a linear number pattern has a constant difference. Okay. So determine the value of x and hence write down the first 3 terms of the number pattern. So I just quickly rewrote the terms with more space in between so we can see it a little bit better. And then we know the constant, that it has a constant difference. So if it has a constant difference, that means the difference between these 2 terms and the difference between those 2 terms have to be equal. So what we are going to do is we're going to find the difference of each and equate them. So we always take the second one, so 2x minus, in brackets, the one straight in front of it. Similarly here, between the 2 terms, you take the second one and you minus the one straight in front of it. So now we have 2 expressions. Let's just quickly simplify this one. So this is 2x minus 3x minus 1, right? Because this minus changes both signs. And therefore, this is going to be negative x minus 1. Similarly here, we have 3x minus 2x minus 7. So we have x minus 7. And now we have our 2 expressions just simplified, so it's a bit easier to work with. So because this is a linear number pattern, like we've said before, those differences are equal, so you equate them. You can put the equal sign there in the middle if you want to, and then work from there, or you can make a new sum if you want to. I'm just going to do a new one for space reasons. And then we just have to solve for x. So I'm going to take this negative x that side, just because then I don't have to work with negative numbers, but it doesn't really matter. So we get a negative x to the other side by adding x. And then I need to take my negative 7 that way by adding 7. So I have 2x is equal to 6. And then I just want to find x, not 2x. So I divide by 2. And then x is equal to 3. So now we've solved for x. But that doesn't answer the question yet. That saying find x. Okay, so we've done this whole part over here. But hence write down the first 3 terms. So we just need to do that portion still. For space reasons, I'm not going to do it here on top. So we have to find term 1, which is 3x plus 1. Term 2, which is 2x. And term 3, which is 3x minus 7. We calculated x to be 3, so I'm just going to substitute that there. And then you're going to get answers 10, 6, and 2. And you can double check from 10 to 6, we are minusing 4, and then again, we are minusing 4, so it does check out. This is a linear number pattern, we didn't make a mistake. And if you want to, you can write then there for the number pattern is 10, 6, 2 if you want to, but this is also sufficient. In the next video, we're going to be looking at application of linear number patterns.